Okay, everyone, last but not least, we're going to end this section with our application problems. So number 5, in hockey, a goalie behind the goal line can only play a puck in the trapezoidal region. Now remember, trapezoid is a quadrilateral. It has 4 sides, and 2 of the sides are parallel. The other 2, not so much. So if you take a look at the picture down here, this is where the goalie would be, and that shape right there is a trapezoid, and what it's telling me here is he can only play the puck if he's in that region. Otherwise, he's got to kind of do something else. For those of you who actually play hockey, I apologize at my lack of knowledge, although I do like hockey, and my team is the Pittsburgh Penguins. If you don't agree with that, don't tell me. Okay, so anyways, it says write a polynomial that represents the area of the trapezoidal region. Now, area, remember, is the amount of space inside. Area of a rectangle is length times width, or base times height. Area of a triangle is 1/2 base times height. Area of a trapezoid, we could cut it up. You know, we could come over here and say, okay, well, the area of that triangle, the area of this triangle, the area, and that's fine, but in order to make this easier, I'm just going to go with what is the area of a trapezoid. If you don't know, Google. Google is your friend. Okay, just type in what's the area of a trapezoid, and it's going to give you something like this. Area equals 1/2 h b1 plus b2. Now, h is the height. The height, remember, kind of goes straight down the middle, forms a right angle. b1 and b2, base 1 and base 2. So if you're looking at your trapezoid over here, here's your height, goes straight down. Base 1 and base 2 are the parallel sides. Here's base 1, here's base 2. And it really doesn't matter which one's base 1 and which one's base 2. It doesn't matter at all. It's just they better be the parallel sides. So if we're going to write a polynomial that represents the area, we're going to take that formula and we're going to see what happens. So the area is going to be 1/2 the height. Well, the height is that green part, which is going to give me x minus 7 times the blue bases. So base 1 plus base 2. So base 1 is x plus base 2 is x plus 10. Now, the first thing I'm going to do here is I'm going to try to simplify. So area is 1/2 x minus 7, and then I've got in here x plus x, 2x plus 10. Now, at this point, I'm looking at that 1/2, and I would have to distribute that 1/2. If you're going to distribute it, keep in mind, we had this conversation, you only distribute it to the first one. Okay, you wouldn't distribute it to the x minus 7 and the 2x plus 10. No, that's too much. You would only distribute it to the x minus 7. But that's going to give me something really weird. That, 1/2 times x is 1/2 x, but 1/2 of 7, that's not pretty. So I don't want to do that. So don't touch it. So instead of multiplying with the 1/2, I'm going to multiply these two. Remember I said you can only multiply 2 at a time? We don't have a rule for multiplying 3 at a time. So instead of doing the first 2, we're going to do the last 2. In order to do that, we're going to distribute. So x times 2x is 2x squared. X times 10 is 10x. Negative 7 times 2x is negative 14x. And then negative 7 times 10 is negative 70. Combine like terms, I'm going to keep the 2x squared. 10x minus 14x is negative 4x minus 70. And then I'm going to go, okay, well, that's the back 2, but I still haven't used that 1/2. Bring it down. Well, now let's take a look at what's going to happen if I have a 1/2. 1/2 times 2x squared. Well, what's 1/2 of 2? It's 1. That's kind of nice. That's 1x squared. What about 1/2 of negative 4? Well, that's negative 2. And what about 1/2 of negative 70? Well, that's negative 35. So an expression for the area of this trapezoid would be x squared minus 2x minus 35. Then I'm going to go look just to make my answer even more beautiful and correct. If you take a look at your picture, do you notice these guys are in feet? So to make this answer even better, put it in parentheses, and this is some measurement in feet. Okay, that's the answer to part A. Now we have to do part B. So part B says find the area of the trapezoidal region when the shorter base is 18 feet. Okay, we'll go look at your picture. Which one is the shorter base? Well, this is the shorter base. Well, they're saying that the shorter base is 18. Well, the shorter base is x, so really they're saying, oh, okay, x is 18. And I want to find the area of the trapezoid when x is 18. So I know the area of the trapezoid is this thing. So if I want to find the area of the trapezoid when x is 18, substitute 18. So area equals 18 squared minus 2 times 18 minus 35. Keep in mind when you're substituting, always substitute within parentheses. Okay, so we substituted the 18 here, we substituted the 18 here. Always substitute in with parentheses. Now, 18 squared, I'm not doing that in my head. Okay, if you're at home and you don't have a calculator, I'm going to show you the calculator you're going to use. If you're in class, this year, because of COVID, we can't even use the classroom calculators. So this year, everyone has a Chromebook. We're all using an online calculator. So open up your web browser. Go to your search bar, type in desmos.com. Okay, so desmos.com. Hit enter. Graphing calculator, yes, we are going to use this, but right now I don't want the graphing calculator. So I'm looking, where is my other calculator? Maybe it's under Math Tools. Yep, click on Math Tools. Okay, typically we use the graphing one, but this time we're going to use the scientific one. In this case, you could probably use 4function, but go scientific. And here's a fantastic calculator. So 18 to the power of 2, and then make sure you go sideways and come back down. I have to flip my screen to remember what this was. 18 squared minus 2 times 18 minus 35. So minus 2 times 18 minus 35. And it's telling me the answer right there is 253. So I'm going to come back. This is area equals 253 feet. And I'm just realizing I kind of have a wrong answer because area is not feet. Area is feet squared, which means back in letter A, I need to put a squared on there. Okay, because this expression represents area, so that should be in feet squared. Last but not least, getting into a little biology here. A combination of 2 genes determines the color of the dark patches of a border collie's coat. An offspring inherits 1 patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. The gene big B is for black patches, and the gene little r is for red patches. Any gene combination with a B results in black patches. Suppose each parent has the same gene combination BR. The Punnett square shows the possible gene combinations of the offspring and the resulting patch colors. Okay, so if you're not that great with this, take a biology class. We're talking about a dominant gene versus a recessive gene. The big B is going to be your dominant gene. So if that shows up, you're going to have black. The only way you're getting red patches is if you've got the RR down here in the lower right hand corner, because that's recessive. It's kind of like having brown eyes versus blue eyes. If you have a brown eye gene, you're going to have brown eyes because it's dominant over blue. The only way you're getting blue eyes is if you're blue. And there's more that goes into it than that, but ask your biology teacher. Okay, letter A. What percent of the possible gene combinations result in black patches? Okay, so this is where we're looking at our Punnett square. What percent of possible gene combinations result in black patches? Well, we've got this is black, this is black, this is black, this guy's red. So that would be 3 out of 4 are black, which is going to give us 75%. Part B. Show how you could use a polynomial to model the possible gene combinations. Okay, well, let's think about this. Suppose each parent has the same gene combination BR. Okay, so you got parent 1 and parent 2. So let's say we've got dad and we've got mom. Well, dad has a B and an R, and mom has a B and an R. Well, there's a little bit more that has to go into it than that, because if dad is a B and an R, well, only 50% of dad is the big B, and 50% of dad is the little r. So that's dad. Well, same thing with mom. 50% is going to be the B, and 50% is going to be the R. And we're going to use our decimals here. So that would be our initial polynomial breakdown. Then, if we want to figure out, well, what's going to happen to a kid, we're going to distribute. So 50% times 50%, or 0.5 times 0.5, is 0.25 big B squared. So that right there would be this up in your Punnett square. That's your BB, which is 25% of that Punnett square. Then we're going to take 50% times 50% of the BR, so plus 0.25 big B little r. Then we've got here to here, so plus 0.25 big B little r. And again, you could write RB, but put it in the same order we put it before. And then 50% and 50% RR is 0.25 little r squared. Combine like terms. Okay, so then I'm going to drop down my 0.25 big B squared. Adding 25 and 25 is 0.50 big B little r, and then plus 0.25 r squared, and that is the breakdown of your Punnett square. 25% right there is your big B, big B. 50%, half of those squares, are your big B, little r, and then 25% are your little r squareds. And if you wanted to know, well, how many are going to give you black patches, you would add these first two, because the big B is dominant, which is going to override that little r and show you black.